Okay, so as promised, I'm going to do some of these ASA economics problems. We'll probably have time for two in a short 10-minute video. So I'll do chapter 11 and chapter 13, and then I'll come back for the other one in chapter 12. So let's begin with number 11.1. In chapter 11, you're given two alternative pavements, concrete and asphalt. The costs for each are listed here: $21 per square yard for concrete, $17.80 per square yard for asphalt. Concrete lasts 27 years before it needs to be repaved. Asphalt lasts 17 years before it's repaved. Now, once they're repaved, the life between repavings, if you will, is equal. Asphalt lasts for 17 years. Once we pave the concrete with asphalt, it's an asphalt pavement, and it's going to last for 17 years. So both alternatives are equal after the first repaving. So, and since the maintenance costs are the same, we can ignore them. Discount rate is 10%, and we're asked, how much cheaper would the more expensive material need to become to be competitive? So we need to do the analysis. Which one is more expensive from a life cycle cost point of view? So the fact that these two lives are different leads me to feel that we should use the annual cost method rather than the net present value method. Okay? And I should point out, if you look at the solution online for this, you'll find that they did a different approach. It's more approximate, and I don't believe that it's correct. I may be wrong, but I don't believe it's correct. I believe that if the lives are different, the best approach is to use annual cost. If someone wants to tell me, show me where I'm wrong, that's fine, but we're going with this. Okay, so we're going to do an annual cost method rather than present worth. So the two alternatives are concrete and asphalt. The lives are 27 years and 17 years. The discount rate is 10%. The initial costs are $21 and $17.80. Now we're going to find the payment for initial costs first, and then payment for repave. And we'll do a repave for each one, just one. Okay? So for the concrete, the payment for the initial cost, use the payment function. Rate, number of periods is 27, and the present value is 21. If we do a payment with a 10% rate, 27 number of periods. Now this isn't a present value now, right? It's a future value. What's the future cost of repaving? So we skip payment and we go to here because that's the cost of asphalt. Okay. And so the total annual cost of concrete up through the first repaving is $2.42 per year per square yard. For asphalt, we're going to do the same thing. Rate, number of periods is 17 because it only lasts for 17 years before it needs to be repaved. And the present value of that is this. And then again, we're going to do the payment for the repave in 17 years. And it's not a present value now, it's a future value. That's how much it's going to cost per square yard in 17 years, we're assuming. And so the present value is 266. So you can see asphalt turns out to be more expensive. So I'm going to subtract those two. Asphalt costs 24 cents per square yard more. So how much would it need to be reduced in order for that material to be competitive? And we can just use goal seek for that. So I want to set that difference to 0 by changing the cost of the asphalt. So the asphalt would need to be $16.11. And I should probably change this to currency. Okay, what's the next question? Next question, well, what's the rate of return with these costs? So back to 1780, and the rate of return is the interest rate that gives a net, well, it gives a difference of 0. So we can't do net present value, but we can do a net difference of 0. So the rate of return, to make these two equal, again, we can do goal seek, value 0, but now we're going to change the discount rate instead of the asphalt cost. So we'd need a 14% discount rate to make this make these two equal. Okay. Actually, wait a minute now. Well, never mind. Okay. It's not really rate of return. I misspoke there, and that's not what the text asks for. It's what discount rate would make them equally desirable. Okay, let's go back to 10% and find the best alternative if the national government pays 50% of initial costs. Well, that's an easy one, right? So we can just divide this by 2. And this would be divide by 2. So even then, the concrete is still the better of the 2. What if we go back to the original and see, the local government allows a discount rate of 6%. Ah, look, concrete is still the better choice. Wow, surprising results there. Okay, so it took almost 9 minutes. So I think I'll quit there and I'll start another video for problem 13.